Hello, it's Acacia Developer here, and today I'm going to be talking about creating an FPS player which can jump. So by the end of this video you should be able to create an FPS controller that can jump. We'll be implementing the camera controls, the movement, and of course the jumping feature as well. So I want to start by creating the FPS player in the scene. I'm going to create an empty game object and then attach a character controller to the empty game object like so, and then I'm going to rename that to player. Now this represents the player's body, or the collider for the player if you like, and then as a child I'm going to create a camera game object and I'm going to rename this to player camera. This is going to be the camera that we view the world from. I'm just going to shift it up 0.9 units on the y-axis, and that way if you have a character controller that has a height of 2 units, your camera should be just peeking out the top of the capsule shape that represents our character controller, which is exactly what we want. Now you may be wondering why I've chosen 0.9 and not 1 like so, and that's because later on when the character controller is jumping, if we don't push the camera down by 0.1 units on the y-axis, then it actually clips through the ceiling. So just a heads up as to why I've chosen 0.9. So now let's create our scripts that we need. The first one is going to be player look, and the second one is going to be called player move. Now what you want to do is select your player body, and we're going to attach our player move to that, and then select our camera and then attach our player look script to the camera. Let's access the player look script. To begin with, in the player look class we want 2 strings that store the names for the incoming inputs for the mouse X and mouse Y axis. So we can declare these strings now. I'm going to call the first one mouse X input name and the second one mouse Y input name, like so. Now below that we want another field. This is going to store the value of our mouse sensitivity, and this is a float. And then below that I'm going to declare a private function called lock cursor, and we're going to call this function whenever we want to lock the cursor to the center of the screen. And to do that we'll simply assign our cursor.lock state with cursor lock mode.locked, and that simply confines the cursor to the center of the screen. And of course we want to do that when the level first loads, so we'll call lock cursor from awake. Now down here what I want to do is declare an update function, and then from the update function I want to call another function called camera rotation, like so. So I'll just call that from here. So in the camera rotation function I want to get the input of the mouse on the x-axis, and to do this I'm going to declare a local float variable called mouse x, and I'm going to assign this with input.getAxis. Now we want to get the value of the mouse on the x-axis, so we pass in the name, which is stored in our mouse x input name string, and then we factor in our mouse sensitivity as a multiplier like so, and then we multiply again by time.delta time. Now we do something very similar to get the y-axis for the mouse. Just need to change a few names. So now we want to rotate the camera. We simply grab hold of the camera's transform and we call a rotate function, and in here we can actually pass in the vector 3, which is the amount that we want to rotate the camera. In this case it's going to be the negative of transform.right, and we're going to multiply that by our mouse Y. So back in the Unity editor I'm going to set my mouse sensitivity to 150 because that's a nice value. And in order to obtain the names for the mouse X and Y inputs, you can navigate to Edit, Project Settings, and then if you click on Input you'll open up the Input Manager, and as you can see I've already extended these out, but you can see the names of mouse X and mouse Y. These are the strings for the names, and simply we can insert mouse X and mouse Y into the string slots here, like so. And then our player look script will be able to find the appropriate inputs associated with these strings, which will be our mouse X and Y inputs. when we press play, we're only going to be able to pitch the camera because that's what we told the code to do. But at the moment, one big issue that I want to fix is the fact that if we look all the way up and keep looking further, we actually flip upside down. And the same when we look all the way down and keep going, we'll flip upside down. So what we want is a method of clamping the camera so we're only able to look 90 degrees up and 90 degrees down and no further. So because of the conversions between Euler and quaternion representation of rotations, it's difficult to clamp rotation axes directly. So in this case, we're using an external variable to keep track of the amount of rotation that we've added and subtracted to our camera, and then we're using this value to clamp instead of using the x-axis rotation directly to clamp. So back in our player look script, what we want to do is factor in a new variable, and this variable is going to be of float data type and called x-axis clamp. And initially we want to set x-axis clamp to 0. In order to pitch the camera, we're using the mouse Y input. So what we can do is add our mouse Y onto our x-axis clamp, like so. So x-axis clamp is going to be keeping a constant record of the amount of rotation that we're applying to our camera, whether it's positive or negative. So if you think about it, if the x-axis clamp is equal to 90, then we know that we're looking directly upward. But if x-axis clamp is equal to negative 90, then we know that we're looking directly downward. For now, I'm just going to hard code these values, but I'm going to add an if. So if the x-axis clamp is larger than 90, then we know that we are looking directly upward. So we clamp our x-axis to 90, so we keep it at 90, but then we set our mouse Y value to 0. Now this is very important because you'll see down here that this rotate function uses mouse Y, so by making this 0, we're essentially applying a rotation of 0. Now I'm just going to copy and paste this below because it's rather similar, but in this case there's going to be an else if, and if our x-axis clamp is less than negative 90, then we want to clamp it to negative 90, and the mouse Y will still set to 0. So as long as the x rotation for the camera is 0 initially, and the x-axis clamp value, you make sure to initialize that to 0, then this should work. But you'll find that the camera is still able to slightly overshoot the clamp. So what we want to do is directly clamp the x-axis to a specific value, and I'll just declare a function down here to do that. I'm just going to call this clamp x-axis rotation to value, like so, and I'm going to pass in, I'm going to have someone pass in a float value, and what we're going to do is we're going to get the Euler rotation of the camera. So we'll access the transform.Euler angles, and then all we want to do is set our x-axis rotation to the value that we've passed in, and then we'll set our rotation back to our Euler rotation value, like so. And now what we can do is up here we can call our clamp x-axis rotation to value, and believe it or not, when the camera is looking directly upward, we're actually at 270 degrees, and down here we're going to be facing 90 degrees when we're looking directly downward. So really this function just stops the camera rotation exceeding the clamp, which can be a serious bug. And as you can see, the camera is now clamped correctly, and we can't look any further and flip upside down. So now that we've got the camera pitching up and down on the x-axis, we now want to implement some horizontal rotation relative to our camera. So in order to do this, we continue to pitch the camera up and down on the x-axis, but the player body is the object that we're going to rotate on the y-axis. And since the camera is attached to the player body, that means it will move with the player body's rotation as well. So back in the player look script, we want a field that stores a reference to our player body's transform. I'll just call this player body. we can now access our player body transform, and then we can rotate that on the appropriate axis using our horizontal mouse input. So in this case it's going to be vector3.up, and then I'm going to multiply that by my mouse X. We'll also need to change this negative of transform.right to vector3.left, or else you'll get some very funny rotations with your camera. And now back in the Unity editor, you'll see a slot for the player body, and you can simply drag in our parent game object from the hierarchy, drag that straight into the slot. But now when we play the game, as you can see, we can look down, we can look up, and we can also spin around to look at our environment. So we're now going to implement movement, so we're able to walk forward, backwards, left and right. So as you can see in the scene view with the player body selected, the blue arrow is always pointing out the front of the character controller, which is where our camera is facing. And the right arrow is always pointing out to the right of wherever the camera is facing. The blue arrow is called the transforms forward vector, and the red arrow is the transforms right vector. So what we can do, when you press the W or the up key, we can instruct our program to move in the direction that the blue arrow is facing, which is our forward vector. And then when we press our A and D keys to walk left or right, we can actually use the red arrow or the right vector. So this is a visual representation of the vertical axis. It returns a value between negative and positive 1. When neither W or S are pressed, the value is 0, but when W is pressed, the value increases to 1, and when S is pressed, the value decreases to negative 1. So by multiplying the value by this axis by the forward vector, if we press W, we're multiplying the forward vector by 1, and therefore we're saying move in the direction of the forward vector 1 unit. On the flip side, when we press S, the value becomes negative 1, and by multiplying the forward vector by negative 1, that gives us a vector that points in the opposite direction of the forward vector, and this is the direction that we want to move in to move backwards. The horizontal axis works exactly the same, but for the A and D keys instead. So now in the player move class, we want a couple of strings that store the names for the horizontal and vertical input. This covers the up and down, left and right arrow keys, the WASD keys, and the arrow keys on your number pad, I think. But essentially it's very similar to what we were doing before with the mouse and Y axes, except in this case we're going to call this horizontal input name. So this is going to be for our left and right arrow keys, or our A and D keys. And then we want another one. I'm going to declare this one on another line, and this is going to be called vertical input name, and this is going to be for your up and down keys or your WS keys. Another thing we want is a reference to our character controller, so I'll just call this char controller for now. And then since this is the actual player body that this script is attached to, we can actually access our character controller directly. What we want is we want to store a reference to it in our char controller field, but we can access it directly through get component. And now what we want is an update function, and we want a player movement function, which will handle all of our character controller's movement, and we'll call this from the update function. So like before with the mouse X and mouse Y, we want a local variable that gets the input, so input.getAxis, and in this case we want to pass in our vertical input name, and then I want a multiplier, so up here I'll declare a float, which will be our movement speed, and then I'll multiply that by movement speed, and then time.delta time, like so. Then we just want one for the horizontal input, which is very similar, so we'll just pass in our horizontal string instead. And now what we want to do is specify the movement, the direction that we're moving in, and the amount that we're going to move in. So in this case we're going to declare a vector3 and call this forward movement. And this is going to be equal to our forward vector, so the forward vector of the player body multiplied by whatever we have for our vertical input, and then we have our right movement. So this is kind of our movement to the side when we press the A and D keys. Then we want to move along transform.right multiplied by our horizontal input, like so. And now we actually want to move our character controller using these values. So we can simply type charController.simpleMove, and then within the simple move function we can pass in our forward movement plus our right movement, like so. So basically I've just added these together so I can actually pass both of these in using a single function call. Now up here you'll see that I've mistakenly multiplied by time.delta time, but we don't actually need to do that because simple move actually applies time.delta time under the hood for you. So back in the Unity editor, if we select the parent of our camera object, you'll see our horizontal and vertical input names. The movement speed for now I'm just going to put at 6. In the horizontal input name box, I'm going to type horizontal because this is the name of that input. I know this, but you can check yourself in the input manager. So horizontal and vertical. So as you can see, for the first time, our player controller has just fallen to the floor and hit the floor. We can still look around, but now if we press W or S, we can move forward and backward, and A and D for left and right. We can also use the arrow keys, and I believe you can use the arrow keys on your number pad as well when number lock is off. But yes, this definitely works now. So now back in the player move class, what I want to do is implement jumping. So first of all, we're going to need a private field which is of Boolean data type, and this is going to dictate whether or not we're jumping in the air. And on top of this, we'll also want some fields that we can access in the inspector, and this is going to be an animation curve, and I'm just going to call this jump fall off. So we're actually going to be using an animation curve to specify how we jump, and then I'm going to declare another field, and this is simply a float, and this will be our multiplier for that curve. We also want to specify a key code, and this will be the key that we use to jump. I'll just call that jump key. So now what I'm going to do is create another function called jump input, and this is where we're going to handle our jump input. And we also need a function that returns IEnumerator. It has to be IEnumerator because we're using this as a coroutine, and I'm just going to call this jump event, like so. And for now I'm just going to yield return null so we don't get any red squigglies. And also don't forget to call the jump input function from the player movement function. So in our jump input function we want to check whether we've pressed our key, so if get key down jump key, where is our jump key? Here. And if we're not jumping. And then what we want to do is set is jumping to equal to true, because in this case we've pressed space and we're now jumping. And then we want to start our coroutine, which is our jump event. So within our jump event we're actually going to use a do while loop. So we'll have our do here and then our while condition down here. And then we want our yield return null to be within our do block. Before our while loop, we want a float variable that keeps track of the time that we've been in the air, and initially we want to set that to 0. Then in here we can specify another float, and this is going to be our jump force, and this is going to be equal to our jump fall off. So remember, that's our animation curve, and we're going to evaluate it at a certain point, and we're going to pass in our time in the air. So now what we want to do is call our charController.move function. So instead of simple move, this time we're calling move, and the move function is used for more complex movements such as jumping. So in this case we want to move in the upwards direction, which is vector3.up. We want to multiply that by our jump force. Then we want to multiply that by our jump multiplier, And since the move function doesn't apply time.delta time under the hood, we're going to have to do that manually in this expression. So time.delta time, like so. And then of course we actually want to increment our time in the air with our time.delta time. So basically this will add a single second into our time in the air. And then below I want to specify a while condition. So while the character controller is not grounded, so if we're not grounded, and we want to make sure that the child controller.collision flags is not equal to collision flags dot above. And basically what this does, imagine the player jumping in a place with a very low ceiling. As soon as the player hits the ceiling, we want to stop moving upward and we want to fall back down. And by appending this to this condition, we can do that. And then any code after this loop, we know that the jump event has just finished. And in this case, we just want to set our isJumping value back to false again. So back in the Unity editor, we now have our new fields that have appeared in the inspector. And I'm going to set my jump key to space. So I'm just going to search for space, like so. The jump multiplier, for now I'm going to set that to 10. And now we can actually specify our curve for the jump fall off. So when you first open it, you'll see a blank graph, but there's a few presets down here that you can select. Usually I like this sort of curve, or possibly this one. And then I take this key at the front, I'm going to drag it up to the top left hand corner. And I'm going to take this latter one and move it down here. And then you can also see that you can manipulate these handles to change the direction of the curve. So this point up here represents when the player initially jumps, and you'll find that the longer that we're in the air, the less and less upward force is applied to the character controller until we apply no new force, and probably at some point around here the character controller begins to fall back to the ground again. And then usually I like to drag this key to around 0.7, and this sort of curve gives you a nice jumping animation. So now within the game, when we press space, as you can see, the player can jump up and down. There is one problem that I would like to address, and it's when the player is right up against a surface like this and walking forward. When you try to jump, you'll get this strange sort of jitter from the character controller. If you back up and jump, then you'll be fine, but it's only when you jump up like this. Back in the player move class, in our iEnumerator jump event, what we can do is we can set the character controller's slope. So child controller dot slope limit. What we want to do is when we begin jumping, we want to set this to a value of 90. But then when we finish jumping, we want to set it back to its default value again, which I think was 45. And as you can see, when we jump, we're now able to get up onto the boxes without the strange jitter, and likewise for these platforms as well. Now, before the video ends, I just want to address one more problem, and that's the problem of the camera clipping through the ceiling. So you may have remembered from earlier that we made the camera 0.9 units high, and it's because of this. So when we jump, you can see that the camera clips through the ceiling and we can see through to the other side. Now, in order to stop this, we have already set our camera to 0.9 units on the y-axis. So all we need to do is go to the camera component, navigate to the clipping planes, and you'll want to make the near clipping plane 0.1. And as you can see, when we now jump, the camera no longer clips through the geometry that makes up the ceiling. Thank you very much for watching this tutorial. Of course, if you found it useful, feel free to like and subscribe. And like always, I shall see you soon.